finding the hotspot with DBSCAN. So we gave standardized district centroid which are XY coordinates into the DBSCAN algorithm and got as output clusters 0, 1, -1. So if I talk about what's another problem in the when I explore with the k-means, k-means gives -1 noisy data points as its own clustering. So it draws borders around all the districts, which is not what we want. We need the dense areas to as clusters. So that's achieved by DBSCAN because it has this epsilon value. So if I talk about the epsilon value, I use 0.6 to get these clusters. If I reduce below 0.6, it will create less amount of cluster, like all this area into one cluster. So if I increase more than 0.6, is also going to create noisy clusters. So these epsilon and minimum number of sample as 3 gave the correct values for the parameters to get the best result. And this geospatial, if I talk about the geospatial data, putting results on the map, that cluster labels I got from the above step, I used to create the as a new column in the geo data frame, and then that link cluster labels used to using the geospatial context. The district name, is shape, and its total places. This step is allow us to visualize the clusters on a map and identify which specific district belongs to each hotspot, as you can see in this Sri Lankan map. Let me move on. So we use matplotlib, geopanda, and to get the heat map, and we use DBSCAN algorithm to generate the map inside the Streamlit application. And if I talk about the result, the main goal of this app to turn raw data into a useful insight that can help people to make better informed decision. And that objective achieved, so we can use available so we can allocate available resources in the best possible way, take necessary action when we in the dense areas, and focus less on the very less amount cases areas. And what did I learn? If I talk about the learning outcome I took, I realize how important is the data set, and how small inconsistencies in data set can create problems. Hello.